Hi, we are the Ram Pump sub team. I'm Maggie, and my other sub team member is also Peyton. And the purpose of our sub team is to design a vertical hydraulic ram pump to deliver water from a lower elevation to a higher elevation without using electricity. Let's get ram pumped. Woo! So basically the whole water treatment process is there's a chemical stock tank, and it goes into the water treatment, and after all the water is treated, like some of the clean water goes to be distributed to the communities, but also part of it is pumped up with the ram pump to continue making the chemical stock tanks, because you need like clean water for like the chemical stocks. And as mentioned before, like no electricity is involved. And the location of the ram pump is at the basement because of the treatment plant, since the water treatment is gravity based. So all of the water is being treated downwards, and the ram pump is required to like pump up the filtered water upwards back to the chemical stock tanks. And like here's some pictures. And here's a video of the ram pump being tested at Gracias in January 2020. That's Alicia. And basically what she's doing is trying to gauge how much force the springs would need to like act on the ram pump and stuff, to get like a rough estimate, since this is just a prototype.
So there's two main parts to our ram pump system right now. We have a 3-spring system at the top of our apparatus, and we have a check valve and plate system at the bottom. Our previous iteration of ram pump only had the check valve and an integrated spring within the check valve system, and that acted solely as the ram pump. But we decided to change the spring system into an external component, mainly because it was easier for plant operators to access the system through this like external spring system. Also, we made it, instead of a singular extension spring, or a singular compression spring inside of the check valve, we opted for 3 external extension springs on the outside. And the main reason we wanted this was because it was easier to individually adjust each spring when there was either less water being pumped through the water treatment plant or more water. And that would help if we needed to vary the amount of spring force for each situation. Okay, go. So here's our experimental lab apparatus that's in the Eau Claire lab right now. So from the front view, you can see that at the bottom, we have a sump pump, which pumps water up into the head tank. And in the head tank, we have a backflow valve that helps us keep a constant head height value, which makes it easier for us to calculate how much force is actually being produced with water falling into the ram pump. At the top, you can also see our 3-spring system connected to the eye bolt. And from that spring system, we actually have a steel wire that goes down through the drive pipe and to the actual ram pump, which is where the plate closes, and there creates a pressure difference that pumps water through our exfluent valve into the air chamber, which is where we measure the amount of pressure that water produces. And therefore, the amount of height we can actually pump that water. From the side view, you can also see we have an on valve and a throttle valve for the water being pumped up from the sump pump. And that's just so that we have a reasonable pump rate for water being pumped into the head tank and water isn't being shot out the top. So now we'll go through the ram pump actually working in action. Here you can see the head tank and where we have water going down through the drive pipe into our water collection tank. Here you can actually see the ram pump and the effluent pipe. There's the air chamber, and we actually have tubing running to a peristaltic pump, which calculates to RPM, and we can calculate the flow rate from that. At the top here, we have the 3-spring system. On the sides, we have 2 more constant force extension springs, and in the middle, we have a select extension spring, which helps pull the plate back open when the plate is closed from the water. Also at the end, you could see the backflow valve, which helps us keep a constant head in the head tank. So we weren't actually able to get into the lab space until about, it was available 2 weeks ago. So our main focus these past 2 weeks have been to just get the ram pump back up and running, because a lot of the components were taken apart when they were moving our lab apparatus around in this lab space. Yeah. And outside of physically getting the ram pump back up and running, our main focus this semester was determining how much uncertainty and turbidity was produced within our current system, and how we could remedy this. So our first place that we looked as having a lot of uncertainty was the waste pipe valve in our head tank. We found out that it wasn't actually giving us a very consistent head height value, and that to reduce the amount of uncertainty, we either need to add another backflow valve so that there weren't so many waves in our head tank when the sump pump was pumping water up into it, or we needed to increase the pipe length of the water being pumped into the head tank. We also saw a lot of uncertainty at the throttle valve. This is pretty much a semicircle inside of the pipe, which we closed to reduce the amount of force of the water being pumped up. But that semicircle causes a lot of turbidity, and we're still figuring out a way to reduce that. Another place where we saw a lot of uncertainty was, or there could be uncertainty, was our air chamber. We weren't exactly sure if it was airtight. And as we reassemble the ram pump and get everything back working, we are planning to make sure that the air chamber is actually airtight, so we get accurate pressure readings and actually know how high our water can be pumped. We also want to look into the manufacturing details of the peristaltic pump and our sump pump, because we specifically for this peristaltic pump, we want to know if the RPM rates and the diameters of the tubing that we're using are actually correct, so we know our actual flow rates of water being pumped by our ram pump. So future tasks, they're mainly focused around getting the ram pump back up and running. We want to fix the peristaltic pump. We want to get the ram pump water storage container actually filled up with water so we can run tests. We want to get our computer back working again because we think it was reset, and we want to implement the Procota code into our system so we can actually record meaningful data. And we want to figure out which springs to continue testing with from our previous data from fall 2019.
And the rest of our future tasks is also very similar to as before. We want to overall reduce this uncertainty in the ram pump. And we also want like a tuning system that's more precise than just like eyeballing like how much you like turn the like eye bolts and like fine tune it. And then we overall want to improve the efficiency of the ram pump. And lastly, like in the long term, like we want to like implement all of these like task into like the current iterations of ramp pumps currently installed in Honduras. So if you have any questions and recommendations, feel free to contact either Peyton or me. Thank you.